Chapter 2, Right Triangle Trigonometry. Section 2.1, Definition 2, Right Triangle Trigonometry. In this section, we will look at definition 2 and the cofunction theorem. For the definition set number 2, we consider the right triangle ABC, where C is the right angle. We use the lowercase letter a to represent the side opposite to an angle A. The lowercase b represents the side opposite to an angle B and also the adjacent side to an angle A. The lowercase letter c represents the hypotenuse or the side opposite to an angle C. The 6 trigonometric functions for an angle A are defined as follows. The sine of A is the opposite side divided by the hypotenuse, which is the lowercase a divided by lowercase c. The cosine of A is adjacent divided by hypotenuse, which is the lowercase b divided by lowercase c. The tangent of A is the opposite side divided by the adjacent side, or the lowercase a divided by lowercase b. As you recall, the cosecant A is the reciprocal of the sine of A, which is the hypotenuse divided by opposite, or the c over A. The secant of A is the reciprocal of the cosine of A, or the hypotenuse divided by adjacent, or c over B. The cotangent of A is the reciprocal of the tangent A, or adjacent divided by opposite, or the side B divided by the side A. There is some technique to recognize this definition too for the 6 trigonometric function. The sine is from opposite divided by hypotenuse. The cosine is adjacent divided by hypotenuse. The tangent is the opposite divided by the adjacent, or SOHCAHTOA. And since the other 3 trigonometric functions are the reciprocal of the sine, cosine, and the tangent respectively, so you will have to just find the reciprocal of those values. Example 1. Triangle ABC is a right triangle with an angle C is 90 degrees. Find the 6 trigonometric functions of A. In part A, if A equals 6 and C equals 10, from the diagram ABC, or the right triangle ABC, where C is the right angle, and angle A is the side A is the side opposite to an angle A, which is 6. The C, or the hypotenuse, is the side opposite to the right angle, which is 10. So now the B, which is the adjacent, is still missing. So we are going to find B using the Pythagorean theorem, which is from a squared plus b squared equals c squared. Therefore, the B is the square root of c squared minus a squared, or the square root of the c is 6, or 6 squared, minus the a squared, the c is 10, so 10 squared minus 6 squared, or square root of 100 minus 36, which is square root of 64, or 8. So b equals 8. And then we write our 6 trigonometric functions. For sine of A, which is the opposite divided by hypotenuse, the opposite of an angle A is 6. The hypotenuse is 10, simplified to be 3 over 5. Cosine A is adjacent divided by hypotenuse. The adjacent is 8. Hypotenuse is 10, simplified to be 4 over 5. The tangent of A is opposite divided by adjacent. The opposite is 6 divided by adjacent, which is 8. Reduce or simplify to be 3 over 4. So the other 3 trigonometric functions, as cosine of A is the reciprocal of the sine A, therefore the cosecant of A is 5 over 3. And the secant of A is the reciprocal of the cosine, or 5 over 4. The cotangent of A is the reciprocal of the tangent A, which is 4/3. Let's look at another example. Draw the right triangle diagram ABC, where C is the right angle. The side B, which is opposite to an angle B, is 5. The C, which is a hypotenuse, is square root 30. We are going to find 6 trigonometric functions. We still have to find the side A, which is the opposite of an angle A. By using the Pythagorean theorem, the a squared plus b squared equals c squared. The a is square root of c squared minus b squared. In our case, the c is square root 30, square root 30 squared, minus the b squared, which is 5 squared. Simplify to get 30 minus 25, or square root of 5 for the side C, or the side that opposite to an angle A. Next, form the 6 trigonometric functions. Sine of A, which is the opposite divided by hypotenuse. Opposite is square root 5. The hypotenuse is square root 30. We can simplify, rewrite the numbers under the same radical, which is square root of 5/30, or square root of 1/6, or 1 over square root 6. The cosine of A is the adjacent divided by the hypotenuse. Adjacent is 5. The hypotenuse is square root 30. Excuse me. And the tangent of A is the opposite over the adjacent. The opposite is square root 5. The adjacent is 5. And then for the other three trigonometric functions, the cosecant of A, which is the reciprocal of the sine of A, give us square root 6. The secant of A is the reciprocal of the cosine of A, which is square root 30 divided by 5. And the last one, the cotangent of A, is the reciprocal of the tangent A, which is 5/square root 5. Example 2. In each right triangle below, we find sine of A, cosine A, and the tangent of A. From the given diagram, the opposite side of an angle A, or an angle theta, is 1. The opposite to the angle B is the square root 10, and the hypotenuse is x. So, since we know the value A and B, or the opposite and the adjacent sides of an angle theta, we can find the value C by using the Pythagorean theorem. From a squared plus b squared equals c squared, and a squared, which is 1 squared, the b is square root 10 squared equals c as the x squared. Therefore, the x squared equals 1 plus 10, or 11, gives us x equals plus minus 11. For this case, this is the right triangle diagram. The side of the length must be positive. So x equals square root of 11. And then use the definition to form the sine of A, cosine of A, and the tangent of A. The sine A, which is the opposite divided by hypotenuse. The opposite is 1 divided by hypotenuse, which is square root 11. Next, the cosine A, which is adjacent divided by hypotenuse. Adjacent is square root 10. Hypotenuse is square root 11, or you can write as square root of 10/11. The tangent A, which is opposite divided by adjacent. The opposite is 1. Adjacent is square root 10. And in part B, the given diagram gives the opposite side to an angle theta or an angle A is x. The opposite side to an angle B is 2. And the opposite side to the angle C or the hypotenuse is 5. We're going to find x using Pythagorean theorem again. So a squared plus b squared equals c squared. In this case, the a is the x, which is the missing value. So x squared plus the b, which is 2, 2 squared, equals c, which is 5, 5 squared. The x equals 25 minus 4. Take the square root or give us square root 21. So x is square root 21 and form the sine of A, which is opposite divided by hypotenuse. The opposite is square root 21 divided by hypotenuse, which is 5. The cosine is adjacent divided by hypotenuse. The adjacent is 2 divided by hypotenuse 5. The tangent is the opposite divided by adjacent. Opposite is 2. No, sorry. Opposite is square root 21 and divided by adjacent, which is 2.